Hello, I have created my project on the topic closed question prediction on Stack Overflow, where I will be predicting whether the questions posted on Stack Overflow will be closed or not in the near future. Apart from that, I will also be predicting whether what was the main reason for closure of such questions. Generally, in Stack Overflow, the questions are being closed for four main reasons. If they are exact duplicate, first one. Secondly, if they are off topic. Third is if the questions are subjective. And fourth is if the question is not a real question at all. So these were the four reasons why Stack Overflow closes some questions. So now I would like to tell you about a data set that I have used here. So the source of my data set was Stack Exchange, where Stack Overflow dumps its database of all the previous years. So one can run a SQL queries to obtain the data set of Stack Overflow from Stack Exchange. So this was the data set in which consists of post ID, user ID, command, body, title, tags, repetition, experience time, website URL, and there were 35 such columns in these, which consist of different features. So apart from this, pre-processing this a huge large amount of data set was a big challenge for me, as there was some missing values in there, as it, and there were some duplicate values. So I can show you some duplicate values here, like what I did. Yes, like as you could see in the cell 41, what I did, there were some duplicates posts here. So just have to remove those duplicate posts. So this was the first part that I have to deal with in this. Apart from this, I also has to deal with missing values. So like for missing values, what I did, there were some NaN values present here. So yeah, so I have replaced this NaN values from zero, as you could see here. So this was some pre-processing part that I did for missing values. Okay, and the other big challenge for me was like which classification algorithm should I use for prediction of closed questions. So for that, I basically used three algorithm, and that those were logistic regression, random forest, and support vector machine. And how do I decide that to which why only these three classification algorithm and not other classification algorithm? Those answer were you will get here in analysis part. So in this analysis part, what I realized that there was need of only these three algorithms, which would be best suitable for me, as I just analyzed each and almost every feature which were present in the data set. And after visualization part, I made this conclusion that I will be using this three algorithm: logistic, random, and support vector machine for my prediction part of whether the question will be closed or not. So there are some four files in this analysis part. You could just go through these files, and there are some visualization which helped me conclude to use which type of algorithm to use. So I have used pie chart, bar graph, and a different visualization method to visualize my features and compare them with my output. So I have these compared this feature with my output to get whether whether this feature can be used for prediction or not. So basically, this analysis part gave me a lot of insight in the data set. Like you can see, there are six number of lots and lots of features that I used for analyzing part. I have visualized all the data set and compared this from my output. These are the four files, which consist of analysis part. Okay, and yes, now the major problem I felt was like which set of features should I use for like prediction part. Like so, there were some features that I can derive from those already existing features. So I used feature engineering here. As you could see, I have used feature engineering here. The feature engineering I used here to get some like uppercase count get sentence count, get length of line, number of URLs in the data set. So these were some of, or what I can say, these were some of the new features that I generated with the help of feature engineering here. So these features were used for in the prediction part too. And apart from this, the one more problem I faced here was like there were the sentences were written by normal people, so they were like too, I can say, too normal text. So I had to remove some stop words, some type of problems. So also there are some have written those texts in other languages too, like Hindi languages. So I have to remove this relevant data. So handling this type of data was too difficult for me. So I have to remove all these things, which I did here. Apart from this, now the I would like to tell you more about what I did in this, what I predicted. So let's go there. So this was the logistic regression. I used a logistic regression for my prediction part in whether a question will be closed or not. So you could see here the same method I did. I used a data set here. So you could see here I employed the traditional method of what everyone else uses here. The standard scaling, fit transform, and just let's get the standard training and test split. And after it, here I have used in this CL61 the logistic because I have trained my model here, and I obtained this accuracy here. You could see 88% here in logistic regression. In random forest, I have I have employed the same approach to here, and here also the result for almost same. Like you could see here in this test set, precision recall and F1 score of 0.88, 0.92, and accuracy of 0.9. So almost a similar job like the logistic regression. And here I have inspected the importance of feature, like which were the most important features. So I found that code length was the most important feature in the prediction part. And here it is, support vector machine. This was the best model for prediction of closed question, as after running all these three models I realized, okay, so this was the best one. And then that too, support vector machine with RBF kernel. I initially used a linear kernel. I do not achieve the great results, as you could see here. And after evaluating performance, okay, so here it is, our training support vector machine with RBF kernel. So it is slightly better performance than previous models, 0.91, 0.90, and 0.91 of precision required F1 score and accuracy of 0.9. So performed a much better, a little better than the previous two. Okay, so this was the first part of my project. Okay, and the second part was, okay, so the second part was whether the question, whatever the reason of close of such questions. So for that I have used that was also a classification task, because I have to predict out of like what was the main reason for closure of such questions. So that was also a classification task. So I have used support vector machine, logistic regression, random forest, and adabos too. Okay, so let's get started with logistic regression again. So here I do not obtain the two great results here, as you could see here. By employing by I have used the same approach here like in the previous one, but here I have to predict this comment. This is the what the prediction part here. This comment, sorry, this comment, this you could see here. This is the one that I have to predict here. So by taking this in the Y, now I obtain a training accuracy of 40%, and also the test accuracy here after like training the model with logic regression. You could see here I got a training accuracy is 0.4, that is 40%. So this was the test accuracy also, like same similar 40% test accuracy I received here. Yes, you could see here. Yes, in this cell 32. Similarly, I did for random forest by using the same approach. You could see I just got this training, got great training accuracy, but not good test accuracy. As you could see here, precision required F1 score, but not too great in this test set. So yes, not too good. And similarly, I used support vector machine too for this task, but once again, not too great work for support vector machine too. I have used with RBF kernel, linear kernel, but okay, but the results were not too great as you could see, not too great results. Okay, so then I used the ADA boost algorithm for this and I obtained a great results here. Then I used to predict the reason for closure of such questions and I found it ADA boost worked the best by using the similar approach. Like here I used ADA boost, like by default it uses decision tree. So here it is, like it gave me accuracy of 0.40, which was like better than the previous models that I used. Actually, ADA boosts the performance of the model. So I have used ADA boost with linear regression to here with linear support vector machine, but obtained accuracy 40% and logistic regression I obtained accuracy of 13%. So yes, by default, ADA boost with decision tree gave me the best result of accuracy of 0.40% in test set. So yes, that was all about my project, what I did. Now I would like to tell you more about what this project taught me. Like what I realized here, that you just can't predict from the 400 what which classification algorithm you should use for your data set. Like exactly, you can't point out any one a classification algorithm. Like okay, so after analyzing and visualizing my data set, what I realized, okay, that these were the three classification algorithm that I shall use, but I can't point out one. So I have to run my data set for from all these from all these three uh, from all these three algorithms and find out, okay, that this one is working the best. So here you could see here in this demo file, what I did, I have just loaded my patent model, so support vector machine here, and use this one for prediction. So yes, this is my results. So where I used the support vector machine, this is the result in cell 3424. Huh. So what I realized, that you can't predict from, you will have to run your data set from the different algorithm to find out which one is best for your data set. This was my first takeaway. Okay, so this one is for second one, the reason for closure of such questions. Here also I have used the same, using feature scaling and all. I use feature. Yes, here's the prediction part where I used a boost classifier. Okay, so this is the actual and the predicted part, and model performs accuracy and F1 score of 0.42 and 0.42 here. Yes, this one is okay. And here also I use this feature engineering and all the stuffs here. You could see here this lowercase count, uppercase count, and everything. And okay, so my major second takeaway was like processing large data sets, dealing with large data set. This project has taught me that how to deal with large data sets, how to deal with missing values. So this was the second takeaway that I would like to tell, that what this taught me. So this was the second thing. Apart from this, my third takeaway was like I learned a lot about visualization and all stuffs here. So like in analysis part, I used a lot of visualization. So I learned a lot about visualization and all stuffs here. As you could see here, bar graph, pie chart, and everything. I learned a lot about the visualization analysis part in this project. Apart from that, I learned a lot about the natural language processing in this project, like in its libraries like NLTK, TextStat, and apart from this, I also learned a lot about the readability metrics like gunning fork index that I used as a feature for predictions. Like you could see here, getting fog index, flash reading is, Dale charitability score, smog index, Coleman Leo index. So these were the few things that I learned from this project. Apart from this, I learned a lot about classification algorithm and their practical usages in this project. So and how to use SQL queries and how to use complex SQL queries to extract data from a data set. This was also a major takeaway, like that, like how to uh, extract data set from a database. So there were a lot of learning in this project. Overall, I enjoyed working on this project very much. So that's all from my side.